Imagine you're a computer science teacher, juggling 20 plus students, each writing buggy Python code, each needing feedback. You got lessons to plan, emails to answer, and a mountain of marking waiting to be done. You most likely lack a relevant degree to teach computer science, which makes your work even more challenging. And you are part of an increasingly overworked and understaffed workforce that is being asked to teach with limited resources. Hi, my name is Sebastian, and I will be telling you about my work designing an AI system for Kita, a new platform that seeks to address these challenges. We started by talking to teachers, and what they told us was very clear. They wanted something that works like they do, that follows their workflow, that gives them flexibility, clarity, and control. With this in mind, I say to build a multi-agent system made up of three distinct models that allows the teacher to stay in the loop all throughout. Let's have a close look at each of these models, starting with the rubric generating agent. Teachers care a lot about rubrics. They are the marking schemes used to evaluate the student work consistently and fairly. The problem is that there is no one standard for how to build them. Different schools and teachers would use their own criteria and grading levels. From my conversations with teachers and review of the literature, I selected these 5 marking criteria as my starting point. I then fed this framework to the rubric generating agent alongside a specific coding problem and had the agent generate a rubric tailored to that task. The teacher gets access to this rubric and can modify it if necessary before any AI-assisted marking is done. Here's an example of a common beginner coding problem, FizzBuzz. And this is a generic one-size-fits-all rubric that a teacher would normally use. But now our agent can generate a rubric that is grounded in the actual coding problem and that explains specifically what to look for in a student submission. We can then move on to the marking agent, which is given a student submission alongside the task-specific rubric generated by the previous agent and produces suggestions for what marks to give to that student. It also provides comments that the teacher can review, tweak, and use to guide their own marking work. Consider this submission, which contains a couple of subtle mistakes. The agent evaluates it against the rubric criteria. It suggests marks, and most importantly, it justifies its suggestions in a language that the teacher understands, referencing specific parts of the student code. For complex problems where students might take wildly different approaches, this kind of assistance can save considerable time for the teacher. And then comes the final agent, the feedback generator. Its job is to take the task-specific rubric and the structure markings of the student work to generate clear, actionable feedback that is targeted to the student. The teacher again has the opportunity to modify this feedback and adjust the tone and level that the agent should use based on the student needs. Here's an example of such feedback. It's kind, specific, and actionable. It references the student's actual code, and it's aligned to the learning objectives set by the teacher. Having this multi-agent workflow in place, I decided to explore ways to evaluate and refine the outputs of these agents. I follow a critic agent-based approach, a method increasingly used in AI research, where one model evaluates the work of another. In our case, the critic follows principles from pedagogy and learning science to assess the performance of the other models. It generates scores for each of the main agents and suggests improvements. Here is an example of the type of feedback generated by the critic agent. Using this feedback, we can then refine the prompts for the original agents and track the scores to check if the changes actually make a difference. And they do. I ran over 100 real-world student submissions through the pipeline, and after refining the prompts using the critics' feedback, I saw a clear improvement in performance across all 3 agents. We also tested the full system with experienced coding teachers from rubric to feedback, and the response was very positive. They greatly appreciated the time savings, the adaptability, and the fact that the AI didn't replace them, it supported them. In conclusion, this is an AI marking system that is modular, aligned with real teaching practice, and it's built to adapt. This is what it looks like when AI doesn't just enter the classroom. but it speaks the language of the people who teach in it. I will leave you with this quote by Sal Khan. You won't be replaced by an AI, but you might be replaced by someone using AI. Thank you for listening.